Today we're going to talk about seismic waves and how we measure earthquakes. Earthquakes can be very terrifying events, especially if you don't know what's happening or why it's happening. So we're going to go over today how an earthquake event occurs and also some things that scientists are doing to try and predict when earthquakes may happen in the future. Earthquakes typically happen underground. The location where an earthquake begins is called the focus. The place closest to the focus at the actual surface or crust level is what we call the epicenter. Seismic waves are really earthquake waves, which is energy released at the focus and traveling out in every direction. Seismic waves come in three types: primary waves, or P waves, secondary waves, or S waves, and then land or surface waves. Primary waves originate from the focus of the earthquake, and they move in a back and forth type motion. Now they can travel through solids as well as liquids in the different layers of the earth, and they travel very, very quickly. You can see a simulation here using a slinky. Secondary waves also originate from the focus, but they move in a little different way. They go side to side, and because of that, they travel slower than the P waves, so they always arrive second, hence the name. Secondary waves can only move through solid layers of the earth. The third type of seismic wave is called a land or surface wave, and these waves move like rolling water waves. They originate from the epicenter, so that's a little bit different, and these are the most destructive type of seismic waves. Another type of wave created by earthquakes is a tsunami wave, and this is a large ocean wave caused by an earthquake. So the way it works is that there is an earthquake under the surface of the ocean, and it moves a large section of water. And then waves will travel out just like ripples in a pond in every direction. The big difference here is that these waves are moving many thousands of feet of water at incredible speeds. In the open ocean, nearly 500 miles per hour. And as they travel towards the coastline, they begin to rise up out of the ocean. And because of that, they become very, very tall. And there's not just one tsunami wave, but they travel in groups. So when one tsunami wave crashes on the shoreline, another one comes shortly after it, and it becomes this never-ending rush of ocean water onto the coast and obviously inland. It picks up a lot of debris, and people caught up on it, oftentimes, if they don't drown, they are going to get bashed around with the different debris and garbage and bits and pieces of buildings and cars and anything else that tsunami wave picks up. They're going to become very, very injured if they're lucky enough to survive. So tsunami waves are a result of earthquakes in the ocean, moving a large section or column of water.
This is after a major earthquake hitting Japan Friday afternoon. Obviously, cars, trucks. You can see some of the tsunami, and it looks like some fire breaking out in the Sendai area after the tsunami has hit. Major earthquake that was revised to magnitude 8.4. One of the largest earthquakes ever to hit Japan. The tsunami has already engulfed some cities, fires breaking out due to the earthquake. In northeastern Japan's Iwate Prefecture, tsunami waves of over 4 meters were observed soon after the quake. The agency is in the Sendai area, Miyagi Prefecture, north of Japan. For those of you who have just tuned in to NHK World, a major earthquake hit Japan Friday afternoon about an hour and 10 minutes ago. Japan's meteorological agency says the quake measured magnitude 8.4. It has revised it upwards to 8.4. The agency has issued a tsunami warning for Japan's Pacific coast. In northeastern Japan's Iwate Prefecture, tsunami waves of over 4 meters were observed soon after the quake. The agency is warning that the tsunami could reach between 6 and 10 meters, currently contacting local governments and related agency to assess the extent of the damage. Tsunami has already struck, and you can see some of the damages so far in Miyagi Prefecture, northern Japan, and the Sendai.
Oftentimes you'll hear people refer to different earthquakes based on the magnitude or the amount of energy released during the earthquake event. And usually they're referring to a number on the Richter scale. The Richter scale basically goes from 0 to maybe about 10 or so, and every level you go up is 10 times more powerful. So for example, a 6 on the Richter scale doesn't sound that big, but it's equivalent to the atomic bomb dropped by the United States on Hiroshima, Japan during World War II. And when you go from a 6 to a 7, that's 10 times more powerful. So every level you go up is another 10 times stronger than the one before it. Although it's not used as often, an alternative way to measure the magnitude of an earthquake is on the Mercalli intensity scale. And this one looks at the amount of structural or geological damage done by an earthquake. Generally, it goes from about a 1, no one really notices, all the way up to roughly a 12, which is total destruction of all buildings and things in that area. You might wonder how scientists know where earthquakes begin. What they do is they gather these paper copies called seismographs from stations all over the world, and they compare the P and S wave arrival times. The longer the waves take to arrive, the further away from the earthquake epicenter that station is. In order to really figure out where an earthquake started, though, you need information or data from at least 3 different seismograph stations. And then they apply that to a process called triangulation to really narrow down that epicenter of the earthquake. One of the goals of seismologists around the world is to be able to predict earthquakes, but it's very, very difficult. What seismologists will do is they'll take their different sensors and scientific instruments, and they'll study areas that are known to have seismic activity. And what they're looking for is some type of pattern or clue as to when the next earthquake might be coming up. And what they're really tracking is the stress that's built up in the rock and trying to make an educated guess of when that stress might be released.
So the Oakland A's take.
Tell you what, we're having an